Welcome
In
back,
progress
viewers
already.
and listeners. We are officially at the fifth episode of our podcast, The Philosophical Outlook. Once again, we are joined by our co host, Nabil Abdul Kader. And today, the topic we are going to talk about is epistemology and the theory of knowledge. So, Nabil, once again, thank you for joining. How are you feeling? You feeling good?
I'm feeling good. I'm in the mood to. Should I? I don't know. Do I feel good? How do I know if I feel good?
How do you know?
I- I-
Good question.
how do I know? But how do I know if I exist? I feel good. Good. I feel good. Three things. I feel good. How do you know if
Yes.
I exist? How do I know if I
Mhm.
feel? And how
Mhm.
do I know if it's actually good? Ah,
These are
wow.
actually no matter how sarcastic they sound, these are actually real questions that philosophers try to answer, and that is what we're going to dig into today. So
Wow, the coincidence. Wow.
the topic that we have today is the branch of philosophy that is known as epistemology, but in a more simple sense, it's basically the theory of knowledge. So the idea here is that philosophy comprises of questions that question the nature of things, right? So for example, metaphysics is like, how is material made up of, how is non-material things made up of, etc., etc. But epistemology itself talks about the nature of knowledge, that how is knowledge made up of, and hence tries to actually answer all those questions that you have been asking, that how do I know whatever I know, right? So that is, I mean, jokes aside, I understand, even within the circle of philosophers, when we talk, we have like a great in-depth conversation. At the end of the day, we are like, you know what, it gets overwhelming. So jokes aside, like, would you say that, as somebody, not a philosopher, but still a person of rationality, still a person of logic in your day-to-day life, do you think you ever come across questions like, how do I actually know what I know, or how do I know that what I know is true? Do you think you ever find yourself pondering over the nature of knowledge? Because I think that is the basics of how and why epistemology exists in the first place.
Okay, so first of all, let me be the grounded person here and say, come on, like some things just make sense. One plus one is what? One plus one is two, right?
Okay.
Is a square a circle? Yes. No, a square has four sides, all right? A circle has like
Okay.
infinite amount of sides, all right? Let's make
Okay.
it simple, right? Then we come to the question of, like all these things. Let's make it practical. I'll receive a WhatsApp message from my
Mhm.
parents saying that, oh my God, like COVID-19, how do you cure COVID-19? Don't take the vaccine. Don't worry about the vaccines. Don't worry about all that crap. All you
Mhm.
have to do is take this, take a piece of onion, right, and put it under your chair, right? The aroma of the onion, you will absorb the aroma of the onion through your nose. Trust me, in 1 week, COVID-19 will be gone, right?
Is that an
This is the
actual
truth.
WhatsApp message you got?
Um, this is what happened. This is what happened. I was coming home and I was going to the dining room, and my dad just grabbed this bunch of onions and he's just putting it under the chair. And I'm like, what are you doing, Dad? Oh, yeah. I'm like, I'm shooing away all these like diseases, right? And I'm like, are you sure that's real? No, we just in case it's real. I'm like, oh, okay. But I'm
That is
like,
such a solid argument, just in case. You cannot argue with that.
let's
Okay.
just try. If we don't try, we never know. I'm like, okay,
Yeah,
now
yeah.
now in my mind, okay, let's try for 1 month. For half the month we try it, and then half the month we don't try it, and then we do the same test, a control measure, all this stuff, right? Scientists. Anyway, back to the main things, right? I received the message. So in my mind, I mean, this is absolutely not true. And how do I know it's not true? I know it's not true because There's articles about it. You can go, online. You can go to, like me as a biomedical background, you can go to PubMed, PUBMED, and you can see all the articles about, like the effects of onion, all this, and they can prove it or they cannot prove it. But what if they're wrong? What if my parents' website sources are right? What if I'm the one who's wrong? So I just go down this rabbit hole of like, why should I trust these people instead of trusting my parents? What is true and what is not true? All these things. So it's all about questioning truth. And I think it's just, first of all, you're already on the right track if you're asking these questions. If you don't ask these questions at all, if you just look at a WhatsApp message and it sounds like from, like someone, the narrative is always like this. Narrative is always like there's someone in Brunei that is a whistleblower. This person is telling you the hidden truth, right? Guys, spread this to as many people as possible. Guys, I'm in the war zone right now. I'm in the COVID-19 facility. And guys, you won't believe what they're not telling us. They're not telling us all this stuff. Spread this message to as many people as possible. And the tone of it sounds legit, so legit. So it gets viralized by people who have this sort of fear. But then when it comes to my, I'm like, I can tell right away because, in Toastmasters, we taught about public speaking. We talked about how to persuade people, how to tackle, how to take advantage of their emotions, how to take advantage of their logic, how to sound very convincing. So these are sort of the tools we use. And I can see those tools being used, but my parents, being not of, from that background, they don't know how to, they don't know the tools that are being used. They just follow their feelings. But again, going back to the statement, how do I know if my truth triumphs their truth? My answer to that is truth is consistent. Truth is consistent. If you lie and then someone asks you, like say for example, Salman, you stole $100 from me. Salman, you stole $100 from me. Give me back the money. And you're like, no, I didn't steal $100 from you. So I'm like, okay, where did the $100 go? Last time I was in your room, and then I asked the people around you, and then the people around, the people around you saw you there, so you take the $100. So you have to convince your other people to tell me that they're lying. So eventually I'll come to the truth. I'll come to an eyewitness that eventually says, no, I saw Salman taking the $100, but if you have a lie, you have to consistently build the lie. Eventually you will come to the truth. The truth is well tested. Science tries to come to the truth. The way science works is that science doesn't tell you that this is the absolute truth. This is the closest to the truth that we can go to. This is the least wrong. That's how science works, right? This is the least wrong. We have proven everything else other than this one. So this must be true. I mean, I'm not sure. Let me know if
I'm not sure if that is how science has been working, at least in the recent times. So here's the thing, right? I think there are a few things. The overall idea that you conveyed about the three things, right? There's truth, and then there is a justification of truth. So that can be like, for example, you said testimony, that somebody would have seen you. So that's testimony, witness, or some sort of justification. So that justification gives sort of like liberty to give support to that truth. So for a statement to be true, and we'll see later how there are very specific terminologies for epistemological ideas to actually explore these. But for the sake of this conversation, I believe that the idea that science does some sort of elimination is not one that is, I would say, at least it's not the most prevalent idea, right? So I believe that the focus of science, at least in the past 100 or few, maybe 2-3 centuries, has been you have a theory, you have a hypothesis, and then you find supporting evidences once again. So you have a claim, and you find justification for that claim. And if the justification makes sense for that claim, it works. It's a proven theory now. It's not a theory anymore. It's a proven fact. It becomes a scientific fact. But here's I think where philosophy would differ, because we'll see later how philosophy broadly divides these information that we have into different categories of as to how we have these informations. But coming back to the point, I think you give me quite an interesting outlook on how you, as a person not involved in philosophical literature, yet a person of reason, right? So you're like, okay, I get a false rumor, I get something, and I do not know, maybe from scientific evidences, I do not know, but maybe let's just say it sounds too good to be true, or it just sounds bogus, so you can eliminate it. So something like that, some idea about how even common men can actually deduce rationality. But here's what I'm interested in. Why would you say that somebody, let's say your parents, were convinced by the same facts that you were not convinced by? So I mean, maybe your parents did not exactly grow up and learn the same way you do, but let's say they're still learned people, right? They're still most of our parents are learned and working even. So why would you say that? What do you think is the reason that somebody of your or mine level of intellect, which can arguably be, because we do not know how to define intellect, maybe IQ, but it can arguably be less than parents even, and in most cases it is, especially when you consider things like experience. But at the end of the day, we do often see that this is a common scenario, that our parents are getting scammed by these sort of online things. What do you think is the reason? What is your outlook on this?
Okay, let me simplify, right? If I take an onion and go to the isolation centers and put all the onions down their chairs, right? Will there be a dramatic decrease in the amount of COVID-19? And
but
we know
you
that the
have
answer
not
is
done
no.
that yet. You have not done such an experiment, nor does anybody who have not, like, nobody has done it. But randomly you see that in a WhatsApp message, and you know that this cannot be true. So even for your own self, you have not proven it to be wrong, right? But still, something, it's like something is off about it. How come an onion is fixing all this COVID? So maybe you're just putting together the fact that, oh, if that was the case, then WHO would have done it, international organizations would have done it. Something about that it doesn't, I don't know.
All right. All right. Okay, let me put it in more ridiculous way, because in philosophy, right, we try to make examples, all that stuff, right? I'm a short guy.
Okay.
WhatsApp message tells me, here's how to be taller.
I like
Here's
how
to be
I like where this is going.
here's how to be taller.
Okay.
Take a Chupa Chips lollipop, and it has to be strawberry flavor. It cannot be any flavor,
Okay.
right?
Okay.
Take a strawberry flavor, and take it out and blow on it 3 times. Don't do it 4 times. Don't do it 2 times. It has to be 3 times. All right.
Okay.
Now put it on your left nose. Can't be right nose. Put it on your left nose. All right. And then jump up and down 5 times. 1, 2, 3, 4, 5. Right.
What is this
Right?
example? Okay.
On the 5th jump, say alakazam. And if you do it right, you'll grow 1 centimeter taller.
Okay.
Right? Will this work?
Now here's the problem, right? Even before you have tried it, even before you, because when you basically open up the idea of how modern rationality works, we talk about all these things like you were talking about, articles and experiments. But the thing is that a modern man of rationality even though he has not experimented that, he would still, he will read that message and he'll scoff. I was like, what is this? Why is it that he already knows that there's no way this is going to work? And I would like to add in that
Oh,
sometimes there are things that do actually work, some crazy DIY trick, and you at first you're like, there's no way this works, and it ends up working.
okay, fine. All right, you want to go there? Fine. So we're talking about knowledge, right? Epistemology, we're talking about knowledge. How do we know those things, right? I like to think of it as a chemist. Now,
Okay.
In chemistry class, you learn about all these elements. If you react hydrogen with oxygen, you ignite, it'll produce water. You know exactly what will happen if what reacts with what. You react iron with oxygen, you get iron oxide, all these things, right? Is it possible to react oxygen and iron and you get gold? Under a normal lab, no. Why do we say that? Because we know the reaction properties. We know how oxygen reacts with every other element. We know how iron reacts with every other element. We know the characteristics, and based on that characteristics, we can predict. And that's the strength of science, right? Science depends on the foundations of knowledge, on these building blocks of knowledge. First, you have the like the elements. What are the elements? What are the properties? What is considered as an element? It's considered as an element because it doesn't. That's the fun. It can't react with anything else. It's consistent. Okay, what's an atom? All right, that's how an atom looks like, and it's consistent with the models, all that stuff. And then if you test, it is consistent with that. And if it's wrong, there's a whole new field, and then you try to, like how. Okay, I'm diving too far away, but one interesting fact is, for example, if you look at the table of elements, at the bottom of the table of elements, it was filled with all these signs, UUN, UUB, UU, whatever, right? It actually stands for elements that they haven't, let's say, discovered yet. They haven't actually proven that these elements exist, but they know that they can exist. It's very possible. And the way to make it possible is that you take two elements of the same weight. Let's say, for example, like lithium and helium or something, right? And you smash it together, like smash it at speeds close to the speed of light, boom, and then you'll get that element. And once you get that element fulfills all the properties that is predicted. The reason why we know is because the periodic table is structured in such a way that every element within the y-axis or within the x-axis, it has a predictable characteristics. For example, lithium has the same, elemental characteristics as the, like chlorine, fluorine, whatever. I forgot I think this is group 7. They all react the same way. And then it's ascending order. I think the first one is most reactive, and then as you go down, it's very reactive, or it's the other way around. So, but my main point is, it's all very reactive. So even if at the very bottom of the list, there's all these elements that we haven't discovered, we know, based on all the things that we've discovered about the rest, we know how it will react. We know what is the property. We know what is the weight. We know what is, like the electronic valence or something. We know the electronic arrangement. We know everything about this element, even before we can have this element. And one day, in the Large Hadron Collider, which is the largest instrument that they made to smash these atoms together, they smash it, they see the properties, they got the element, and then they name it.
Okay.
Does the element react exactly as they expected? Yes. No, so they don't really need to discover it. They already know all the properties about it, 100%. They just need to discover it to just, oh yeah, oh, we're right. Okay. So it's like, how many fingers? I know you're holding 3. I know 100%. I just need to make sure. All right. Oh, you're holding 3. Fine.
So
Uh,
what happens, because I mean, I'm not a chemistry student, but I'm pretty sure from what I remember back in secondary school that there are exceptions, right? There are exceptions all over scientific. There are exceptions all over science. So we know for sure that there are exceptions in the periodic table too. So let's say, like you were talking about two elements that we know that how they're supposed to react, but we have never done that before. And the day we actually do that, they do not react the way they were supposed to. So what does that tell us? And like
I
how
think
does that go? Does that go against your hypothesis?
right. So I think science, right? Science, I think one of the methodologies is uh, you have to make it repeatable,
Mm-hmm.
which may associate with the truth. So you have to be able to reproduce the results in the same conditions, right? Say, for example, you, you know, are you old enough for this? So you have a film camera.
Okay.
Remember in the old days in the film camera? Sorry, maybe you're not born yet. All right, old days of the film camera. You take a photo, and sometimes there's all these flares. Like
Mm-hmm.
in a film camera, there's all these dots, right?
Mm-hmm.
Does that mean the dots are there? Right?
I have
It
no idea
doesn't
what
mean
you're
the
talking
dots are
about.
there. Oh, are you serious? Oh my God. Okay. Okay. So, okay, maybe.
Look. Okay, I will give you a scenario that I know, and let's see if we can
Okay.
get anywhere from that. Okay, so what I
Yeah.
know is one of the biggest examples of how we cannot just go around and go about, expecting things to work in a certain way, right? Like the periodic table example. So like when Newton introduced the laws, right? So we know from those laws, because they are laws, like you said, they're repeatable, and we have seen that on small scales, on every single scale in this world. Whatever we see, we know is following those laws, right? So if something is moving, we know it's going to keep moving until an external force or an internal body brings it to a rest or change in direction. We observed that, and we observed that several 100,000 times. You're like, oh my god, it's a law. But then Einstein comes in, and he's the guy who has not seen this, who has not seen any of this. But he says, okay, the Newton law, okay, as he very famously writes that the Newtonian laws are accurate and correct unless and until we're talking about the heavenly bodies. And several hundred years later, I mean, maybe half a century later, when we actually go and set up when we increase the diameters of the Hubble telescope and actually observe that it's not working in the way it's supposed to work. So we see the planets and the several other celestial bodies not following the laws of Newton, which are supposedly supposed to all bodies of mass are supposed to observe that. Even, let's take it one step further. So Einstein hypothesized this extremely 99.99% accurate, almost 100% accurate kind of law, which is very famously that no mass can travel faster than the speed of light. And I think very recent discoveries, very recent calculations about the Big Bang and the creation of the universe suggest that because of the size of the universe and the rate of expansion, it does not add up. So we know that there might be a period of time at which the universe was expanding faster than the speed of light. And the scientists are like, that is not possible because it contains mass. But we are baffled. We do not know. So, I might be wrong. There might be more details into it, but
Yep.
that's how I understood from what I read. So my point being, once again, that no matter what, and science is just one field. We see that in our daily life also. We see that there are things that are supposed to work in a certain way, and we assume, okay, they're supposed to work in this way. But at times they do not. At times there are exceptions. Does that mean that our knowledge about them was inherently flawed?
I go to a restaurant, and I love going to this restaurant because it always serves the best roasted
Mm-hmm.
chicken rice
Mm-hmm.
every single day, 365 days a year.
Okay.
And one day the chicken rice was crap. Does it mean that they serve bad chicken rice, or is it just an anomaly? So I think we have to differentiate between anomalies, right? We have to take that into consideration.
I think
All right.
that's a very good example. I think that's a very good example. And enter epistemology. Here is exactly why epistemology exists, right? You just, you brought it in, you just fell right into my trap. You gave a perfect example. You fell right into my trap. And let's break down. Okay. Epistemology works best, you can by universal laws and truths, but it works best when you reduce it to statements. Okay. First off, we take one statement of one instance, right? This restaurant, let's go to this restaurant. Okay. Let's go get some, just, I don't know, give me some dish name. I don't know. Give me a restaurant and its dish name so I can create a sentence example.
Curry.
Curry at Curry Puff. No, wait. Okay, Curry Puff at the Curry Puff house. Okay.
Curry Puff at the Curry Puff house.
So you say, you're like, hey guys, let's go to the Curry Puff house. We are going to eat at the Curry Puff house. Why? Because it has the best curry puff, right? And okay, let's make it more instantaneous so it's easier to trace it down. So you sit down at the Curry Puff house and they give you the food, and you point at it. It's like, this is the best curry puff in whole of Brunei, right? And I take a bite out of it, and it's not good. It may be an anomaly in the greater scheme of rotations, but that curry puff in itself is not the best curry puff in Brunei. So is your statement wrong? Yes. In all definitions of the world, your statement that this curry puff is the best in Brunei is wrong, right? So does that make your knowledge about that wrong? Well, this instance proves that yes, it makes your knowledge about, because when this is, if this is not the best in whole of Brunei, then immediately a second next best restaurant would become best for even that microsecond in which they had an anomaly. The second best restaurant would become the best. You follow me, right? So your statement becomes inherently wrong. So what do you think? Do you think that statements that require external validation we can never know if they are wrong or not?
Let me just be Jordan Peterson whenever someone asks him a question. It depends what you mean by best.
Okay.
Right.
Okay.
So what is best? Is best for individuals or the majority, or for example, Rotten Tomatoes, right? What is the best movie? The best movie is we can say the movie that has 100% rating on Rotten Tomatoes.
Okay.
But you have movies that are so good. Like, for example, like Man. I mean, I like Man of Steel. Or let's say a polarizing one, let's say Watchmen. It doesn't have 100%. I think it has like 70%. And it's not, this 70% doesn't mean that everyone voted 70%. It means that 70% of voters voted that they liked it. So the voting mechanism is, so there's so many ways to quantify what is the best. Is it the best, the highest rating? What is even the highest rating? Is it 100 people say that it is 70? Let's take the
quantitative example, something we can measure. So you say, okay, this movie, so we're going to watch a movie, right? And you say, guys, this movie is the best movie on, it's the best movie. And what you mean by it is that it has 100% on Rotten Tomatoes. So you say that, okay, this movie has 100%. But the second we start, or the second you say that statement, suddenly an entire batch of cinema watched it and they rated it bad, and now it's 99. So,
all right,
is your statement still true?
My statement, it depends on my statement. So it depends on the context of who. I mean, we're talking about. Okay. Are we talking about authority? Okay, so it depends on who gives the statement. Oscars. A lot of people say the movie that wins Best Picture is the best movie for that year. What does the Oscars mean? Does the Oscar mean that they take the entire human population, like, hey, here's a voting ballot, vote whoever do you think has the best movie? Is it done that way? No, they are voted the best according to a list of anonymous voters.
Mm-hmm.
That's it. And these voters, we just trust that they're credible. So it's the best movie by the Oscars. It's not the best movie by me. All right. This is the best movie of the year by the Oscars, which translates to this is the best movie of the year according
Is
to
that
these
how
list of
Oscars work?
anonymous critics.
I didn't know
Yeah.
that.
So
I mean,
yeah. So
is it random people or is it like a committee?
it's a committee. It's a committee.
Oh,
And you don't know who
Plato would be so happy. He he wanted the social system that basically he wanted a shura, that is the Platonian idea of democracy, like he's like
but
a group of elites should do that, but let's not get there. But yeah, continue.
actually you can buy your way into it. I don't know which philosophy this satisfies, but
That's called
do you know about
corruption.
yeah, you with money.
Yeah.
Yeah.
But okay, I get your inherent outlook, right? But okay, let's try and see, let's try and break it down and see if it still relates back to these examples. So we discussed a wide array of examples, real life examples, and they were not Boolean in like yes or no, the central question being that if something change or if something does not change, does it change the fact that your statement was true or not? Yes.
All right. Actually, I like your physics example.
Okay.
I love physicists. You know why I love physicists? Because they have the like most down to earth, right? For example, right? If I have a phone right here, if I have my phone right, this aircon remote, if I drop it, I know exactly at what time the bottom touches the ground. It's unbelievably accurate.
Mhm.
Assuming that air resistance is like
Yeah.
this constant value in a vacuum, definitely. So it's like the precision of physicists is astounding.
Mhm.
Here, we hear about flat earthers, right? I had this imagination in my mind. Can flat earthers launch a rocket to the moon? Can flat earthers launch a rocket to the moon? And my assumption, my belief is that they can't. The reason is because they can't identify what is the truth. They
Like more
ignore, like, how do
specifically, their calculations will not be accurate.
their calculations not be accurate.
Yeah.
Like you can easily know the earth is round. Okay, number one, you can see it, right? Number two, like, I think this is also one of Newton's laws. Any body of mass has a gravity. Even us, we have gravity. If the mass is so big, it has more gravity. And because of that, we're pulled by the earth. And if the earth is flat, it's impossible to generate gravity. Like, as we go through the edges, we'll be squeezed out. There's a Vsauce video on this. I know you like Vsauce.
Yeah.
But the calculation would not match up. So the calculations translates to truth.
See, you mentioned the video by Michael by Vsauce, right?
Stevens.
And I want to say that there are some really, really interesting outlooks that he has taken there, because he does not only just he also talks about the possibilities. I mean, he talks about the flat disk accelerating at 9.8 meter per second, right? He's like, okay, what if it's a flat disk but it's just accelerating? So you also, and this is why I want to discuss epistemology in the first place, because the idea being, and I'm just going to leave this idea, but I would love to come back to it after we actually discuss the basis of epistemology. So maybe we can have a more clear outlook on why we need epistemology in the first place. So the idea is that we have a certain calculation, and I think this has its roots in the fact that we knew that the earth is round, or at least spherical. At least it has a bend even before we actually went out and saw it, right? And this is not, I'm talking like not NASA, as like, travelers who traveled across the world in times when ships were a thing, or even before that, we have the accounts of people like Ibn Battuta and people, even before that, like just nomads by today's
Mm.
standards, right? Something like that. But they and I think even somebody in Greek, I'm not sure if it was somebody Archimedes, or I don't know, somebody in Greek, also Greece area, he also calculated it with 93 to 96% accuracy. So the idea is that uh, that is one way, and it's a very easy way to say, everybody's like, just ship all the earth flat earthers in the rocket and show them that it's round or something. That is a very basic idea, and we will come to that also. But even before that, the way we knew that earth is round or it has a bend was because of some calculations, right? So when they would send convoys, they'd be like, okay, you go from there to there, this is the speed at which the boat is traveling, right? And this is how much days it should take. But it takes more than that. And one of the biggest contributing factors was that if it's actually just between two continents, then they do not have to change the direction of the ship, but they actually had to change the direction of the ship because it's round. So they have to adjust it to fit the sphere. And maybe that's the reason why we have a lot of accounts of historical uh, voyages going wrong, right? They wanted to go somewhere else and they ended up somewhere else. It's because they could not take the curvature in regards. My point being that we sometimes we see and we say, okay, yeah, it is round. You see a round object, it's very easy to say round. Sometimes we deduce, like, since this and this calculation, hence it must be round. So sometimes we deduce, right? So Stevens, in that video, he discusses both. He's like, okay, so because of this and this logic, because of this and this logic, earth is round. But actually, if we consider these ridiculous hypothetical situations, that the earth is a flat disk and the poles are freezing, and something about the gravity not being radial as we think of it. Gravity is radial. It starts from a center point, it has a center of gravity, and it expands out. But what if it's just several hundred points all across the flat disk that all emit gravity at the same magnitude? So basically he discusses that it is possible that there are alternative uh, alternative deductions that deduce that earth is flat. So first off, what is your outlook on that? What if a flat earther could provide you, and they do, if you have plenty of free time, you should go uh, YouTube flat earthers explanations. And they are so convincing sometimes, they are so convincing sometimes. Then so my idea is that what if somebody gives you every single possible explanation? Even I think they have an explanation of why the earth appears round. They have an explanation for that, why the earth
Yeah.
appears round. So my idea is that what if they are able to give you some calculations that deduce that earth is actually flat? Will you be convinced? If not, then what is the primary uh, way? What is the primary idea that convinces you? How do you know what is a fact and what is not a fact? What is your outlook on
All
this?
right. All right. So I think actually flat earthers, if you have convincing evidence, let me know. I will be really happy. You know what makes scientists happy? Scientists happy if you tell them something that contributes to the field.
Okay.
Flat earthers, if you tell me that you discovered the world is flat with all your evidence, I'll be happy. But if it checks out, the nature about physics is that everything checks out. The nature of physics is simply if you go to a physics class, or even if you go to a mathematics class, there's a set of rules that you have to follow, right? And the
Mm-hmm.
questions in the exams are always like this. This is the information that you have, like Ali has a rocket, and then he's going to throw the rocket at 900 meter per second or something, right? At what point does it reach there? And you do all these calculations, and you can do it in real life, and it matches out. So everything in physics, all the equations, you match each other out. Then
Yeah.
the more it matches out, the more it's like true, right? I would like to see a flat earther uh, check out all the equations, because what I noticed about flat earth, they're very they're very scientific in a way that actually they do a lot of experiments. I'm amazed. I was watching all these documentaries and they're like, yeah, it's a sphere and we did all these tests. And you're like, yeah, it's like, I'm amazed by how scientific they are. But it's like the science don't match. And in fact, even in the flat earth community, there's different facets. Some people believe that the earth is a disk, like, and the edges are ice. Some people believe that the earth is like some sort of square. Some people believe that the sun is round and the earth is flat. Some believe that the earth is flat and the sun is just above. So many different things. Even in the flat earth community, they don't cross out each other. And then I was watching this documentary as well. And then it's so full of conspiracy. The flat earthers themselves are conspiracy theorists. And they assume that, like they, whoever they is, are trying to take us over, right? And the leader of the flat earther at the beginning,
Ancient
they were
aliens.
celebrated. and then in the end, there's this, like distrust among each other. Like the lady suddenly got called, like, no, you are honeypotting all the guys to go here. And suddenly they're all like mistrusting each other. Why is that? Is it because it doesn't match? Is it because they're only following their emotions? I don't know.
Okay, so
and then at the end, I'm gonna spoil this documentary by Netflix. I'm not sure if you've seen this.
Yeah, I don't. You think I go around watching flat Earth documentaries?
The end of this documentary is this: these flat earthers want to prove that the earth is flat. So they go around this like field, right? And they have 3 points. So this is a straight field, right? They have 3 points, 1, 2, 3. And in these, there's a pillar with a really narrow slit in each same direction. Pillar, narrow slit, pillar, narrow slit, pillar, narrow slit. On one hand here, you have a really strong laser that shoots straight. On the other hand is the receiver to make sure that you receive, right? If the world is flat, if the earth is flat, the laser will go, no problem, right? And then the documentary ends up with this guy at the other end, seeing here, and they already build it up. They already say that I think the world is, a flat, and then I think we're gonna see the light bulb, right? And then the documentary ends with, oh, I don't see anything. I don't see anything. Oh, that's interesting. That's interesting. And then credits, right? I'm like, okay.
Okay. That's at least they're actually doing some scientific experiments. That's good on them. But see, here's the thing. You mentioned a point that what if these things? One of the problems is that these things are not consistent, right? And I want to differentiate between experiment and deduction. That I want to make this distinction that experiment is something different and deduction is something different. So for the sake of deduction, let's say that just because you think that you find inconsistencies in ideas, does that make the claim bogus? So like you're like, okay, they are doing these calculations, but some of the calculations don't add up, hence I deduce that their idea is wrong. But if that is the case, then our ideas about the Big Bang and the creation of the universe, and even to this day, several calculations about simple calculations about the solar system, about the radius of different planets and different bodies, sometimes they just don't add up. So would you say, like, if I just simplified, would you say that do you believe in the Big Bang? Do you believe that Big Bang happened and hence universe?
Believe, right? Because
I mean,
it's all about faith, right?
We have been taught. So maybe belief is it's a different term. But let's say, are you convinced?
I'm convinced. Yeah, that's the right word. That's the right word.
Yeah.
I'm convinced.
There are all these facts they teach you in school and stuff. So are you convinced that there was a Big Bang?
Yeah, I'm convinced.
So then when I present this document to you that some part of the Big Bang doesn't add up, and there's no one evidence. There's 1,000 different things. We do
Yeah.
not know that what was the cause of the Big Bang. We do not know what was the cause of the imbalance in the Big Bang, because there was an imbalance, hence collision. We do not know why the Big Bang. So, okay, they say
Yeah.
it's expanding. The universe is expanding. It's a big part of the Big Bang itself that it's expanding. But then, like I discussed earlier, that there are certain, it just doesn't add up, the size of the universe, observable universe, or the speed at which it's supposed to is expand, and the time, how old it is, I think 13 point some billion years. So it doesn't add up. So we know that there must be a time in which it might have expanded faster than the speed of light, which we know is not possible. So, you know if all I'm saying is that if there are inconsistencies in the Big Bang theory, do you think that is enough for you to exclude yourself from being convinced that it is true?
Yep. If there's enough inconsistencies. So what happens here is that you prove a very interesting point. In fact, physicists know at which point do their equations fall out. For example, right, E is equal to mc squared, the Einstein's favorite and most famous equation, and all these other equations, they all add up. They all add up.
Mm-hmm.
Uh, uh, where it all doesn't add up is they in the topic, for example, like dark matter. They still don't
Mm-hmm.
know what it is, and antimatter. We are matter, but there's antimatter. If matter mixes with antimatter, there's a huge explosion, right? Why is it that there's more matter that we don't know the answer yet? And sometimes it's like we know all the fundamental forces, or basically we know what the equations are, we know the game so that we're playing, but sometimes there's a hole at the bottom there that we don't know what it is, and we don't know how it affects. I think it all comes down to this: usefulness. If I'm
Okay.
a scientist, and I'm like, okay, my mission is to get these people to go to the moon,
Mm-hmm.
what would I use? Okay, do I use the gravitational theory? Okay, the Earth G force is 9.81 meter per second squared. Okay, do I use that? Okay, useful. I'll use that. F is equal to ma. I'll use that. Okay, whatever it is, whatever I've used, it has worked. It has worked for years. So it's worked. It's been proven. That means that I know that it's maybe it's not true. I don't know, but it works. So it must be true,
I
right?
know where you're coming from. I understand where you're coming from, but that is an idea that philosophers would reject with rather passion. Because you see, this is where philosophy and science sort of parted ways. Because science sort of inclined towards technological advancement, and philosophy sort of inclined towards more about virtue and truth. So for them, truth is inherently truth. It's for I think that the terminology would be that for science, truth is coherently truth. If it makes sense, if it gets the job done, it's truth. They don't care
Hmm.
about anything else. For philosophy, truth is not coherently truth, it's inherently truth. It has to be an absolute truth in itself. Even if if it gets you to the moon, but it's not true, they don't care. You follow me, right? So something, because obviously science does not care about virtue. Philosophy cares about virtue, and that is the area where philosophy and religion kind of merge. So these are things that you may or may not actually ever be able to scientifically even talk about, but we have to discuss the inherent virtueness of them. So for example,
Yeah.
uh, uh, I'm going to take a very random example, and I do not want to get into the side details of it, because once again it steps into morality, a topic that we have been avoiding for so long.
Okay.
But I believe this episode will pave path for morality. The point being, there's some certain guy, and he has done something bad, and he's a bane on the society. There are two things, right? Get killing him, killing him on sight is, it gets the work done. It saves society from the bane, right?
Hmm.
We're not getting into the discussion if it is or not morally wrong, but philosophy adds an extra layer in that says, even if it gets the work done, even if it saves society from the bane, there is still an extra layer of is it moral or not. Reminds me of a beautiful work about, uh, um, Dostoevsky. He I pronounce his name so bad. He's
Yes.
Russian. He wrote this really nice, really fantastic piece of art called Crime and Punishment, and he talks about a person who comes from really underprivileged area, and he has spent a fortune on his education, and he's not getting any, he's in a bad crisis in his life, and he's in a position where he needs financial support, and his family is relying on him, and he's in this really different and difficult state of trauma and problems, and then he chooses to commit a crime and murder somebody, and take something from them, some money or something. I think he sells it to some old lady, and then he kills the old lady. So now there are 1,000 different arguments. He gives birth to the morality problem, as in, you know is it wrong to kill that woman, or what else, what other option did he have? And for him, it got the work done, he got the money, right? But morally, that is questionable. So I'm not going to get into what is morality and what is questionable, but the idea being that philosophy and science, they part ways right here at this point, which is called the debate of virtue, right? So for science, getting things done is the top priority. We have been killing animals and rats and whatnot to get the
How do we
work
kill
done.
more efficiently?
Sorry.
How do we kill more efficiently? If there's capital punishment, how do we murder people easily?
War, yeah, war, and like
More efficient.
Einstein said, no rat would ever create a rat poison, but humanity created bombs. So science and technology has been focused on getting the work done, very less concerned about virtue and morality, but philosophy does not. So philosophy needs to know if something is morally and virtually correct, and then it works on that. So in that idea, what I mean is that for philosophy, a truth should be absolute truth. It just does not need to add up. It needs to be actually true, right? So this is where I actually want to bring in the epistemological illustration of how epistemology works, right? You seem really outthrown. Uh,
Well, true. Okay, what do you mean? Okay, give me an absolute truth.
yeah, yeah,
What's
yeah.
an absolute?
Okay. We'll discuss this just by the illustration, right? So let's talk about epistemology, right? And that will diverge into the concepts of why and where relative truth ends and where absolute truth starts. So let's
Right,
see.
right.
So in epistemology, like I said earlier, we take instances of conversations, right? It's easier to work with. So we have a statement. For example, let's say a statement. Um, Nabil is wearing is that a maroonish brown shirt, right?
Okay.
So that is a fact, that is a fact. And let's not get into how we can prove it, but that's a fact. Now, epistemology essentially deals with several different categories of knowledge, namely know that, know how, know what, know when, know where. So these are distinctions epistemology makes to deal with each of them in more detail. But
Simple, simple.
the kind of I feel like you were expecting way more complex terminologies, and then it's just like that when don't worry, it's gonna get complicated. That's
All
why I
right, bring
took
it on.
such
Down.
that's why I took such a broad outlook on it first. So when we actually throw in the terms, it makes more sense that we can relate it to real world. So the field, the sub-subject that we are concerned with, at least right now, is know that. So which mainly refers to the knowledge of facts. So I know that Nabil is wearing a brown shirt right now. So let's simplify it. I know that I am wearing a blue shirt, right now. So epistemology in the efforts of trying to build a solid foundation of what is knowledge and how do we perceive knowledge, it breaks down knowledge into four categories, right? So one is knowledge itself, but let's see what knowledge is made up of in terms of epistemology. So knowledge says, and this is called the theory of knowledge, right? So what is knowledge made up of? The first thing is claim. So I made a claim, and these are obviously my terminologies, they use rather complicated terminologies. I'm trying to get it more simplified. I made a claim that, oh, Nabil is wearing a brown shirt right now. This is a claim, right? So in epistemology, they call it either an assertion or a preposition, that I imply a fact. I imply the
Yep.
knowledge of a fact. I
Yep, yep, yep.
imply that I know that
Yep.
Nabil is wearing a brown shirt. So that's the
Hmm.
preposition part. But the equation that I like to create is knowledge is equal to claim plus belief. So my belief is that, yes, Nabil is wearing a brown shirt. Now you'll be like, why is belief important here? So belief is important here. And I'm just, trying to define the terms as broadly as possible, so it's
Yep.
easier for us to follow. Belief is important here because of what we call a prepositional attitude in epistemology. So if I
Okay.
am not myself convinced, if I'm like, I think Nabil is wearing maybe a brown shirt, so I do not believe it on myself. So it's very difficult to get a fact out of ambiguous or dubious statement. That is why belief or a confident attitude is very important, that the person who is making that claim actually believes that that claim is true, and hence he's making that claim. If I don't believe you're wearing a brown shirt, if I think you're using some kind of filter and you're turning the green shirt into brown, then I will not make the claim that you're wearing a brown shirt, right?
You
So
have to believe in what you're saying.
you have to believe in what you're saying for it to be a fact. So we get that part done. But here's the part where it gets interesting. For it to be actually true, which means for it to be knowledge, right? Because we're saying knowledge is equal to claim plus belief plus justification. So one way or another, I need to be able to justify my claim and my belief. And for this instance, I can justify that I am seeing you through the webcam right now on my screen. So I can see that you're wearing a brown shirt. So I can, justify my belief and my claim. So basically, in epistemology, the definition of knowledge is justified true belief. Three components that make up knowledge. This is why I asked you earlier, would you still believe or will you still be convinced if you do not have all the facts, if it's not, because that's the attitude of science. Sometimes they do not believe in anything. They're just like, this is the facts, do whatever you want to do with it. So
Salman, what are you smoking, bro? My shirt is dark gray. All right.
Oh,
It's
okay.
only dark brown because you see it through this camera, which I suppose picks up the infrared that you can't see.
Okay.
And you say that's the truth. I
No,
use
it's not.
science.
Yeah.
I use science.
Then this is not knowledge, right? Like somehow it just happened to be this case, but then
So
this is not a
at the
fact.
beginning, you'll be like, that's knowledge. And I'm like, no,
No,
you're
no,
wrong. That ain't knowledge.
So because it's missing one component,
What's
it
the
has the
component?
claim, it has the claim, it has belief, but it
Yeah.
does not have justification of that belief.
You had a justification just now. Your
But it's
justification was
errored. But that justification is errored, right? It's corrupted.
Ah,
I'm
so-
seeing through a filter.
Why is it errored now? You were so confident that it was the knowledge.
Yeah, see, that's the problem. That's exactly why we don't know if our knowledge is actually knowledge. Because what if we're seeing the world through this filter?
All right. So what if you're the anomaly? What if you're the only one with the anomaly? So truth is what is consistent. For me, for higher, for purpose of knowing more, knowledge is something that is consistent. Okay, it doesn't matter if it's useful or not, it's consistent. Are you the only one with an anomaly that sees it as the brown shirt? You
Okay,
know,
so for example, what if something is not consistent for anyone? So we see the world in, I think, 180 degree, or and in a certain color range and a certain degree of point of view. Different animals, literally all creatures, see it slightly different color scheme, slightly different angle of perception. So how do we know which is the real world? Are we
we
seeing?
can we can break it down. Of course, we're not seeing the real world. We're seeing the images that is being processed in our heads.
Mhm.
Uh, I mean, everything that we see is being filtered by our eyes and our brain. But there are some ways to counter that. For example, we know that animals see more than us because like, for example, we see color because there are rods and cones that we can identify they're sensitive to the visible
Mhm.
spectrum. But in animals, their rods and cones are specified to another spectrum. So we know that for whatever reason, they see something differently than us. And maybe we can translate it by machines. We can record something with a machine. We can model it after the same rods and cones, and maybe we can sort of
Mhm.
see what they see. And for infrared, for example, we know that, for example, I think T-Rex or crocodile, they see infrared. We don't know, but we can translate it using infrared cameras.
Yeah, but
But
exactly. Then the question is infrared invisible
it's invisible from our eyes.
for humans?
There,
But
yeah.
so this is in philosophy, this is called the debate of reality. What is the nature of reality? We know that this is how we see it, and human beings that have a tendency that they want to be the center of the universe. So we say infrareds are invisible. Why? Because our eyes cannot see them. But if the eyes of alligators or crocodiles can see them, then it brings the question that in reality, is infrared invisible or not?
So the sentence has to be accurate. Infrared is, I mean, you can be specific, right? You can be specific. You can say, uh, infrared is invisible. Wait, who am I talking to? I'm talking to human beings. Of course, it's invisible. Now, suddenly, 1 million years has passed. Like
Crocodiles have evolved.
crocodiles have evolved. Apparently, the conspiracy theory of lizard man have come true, right?
Slender man.
I don't know what happened, but millions of years of bestiality have risen up to have crocodiles. I don't know what happened, right? Something happened, right? So crocodiles come in, and I'm talking to a crocodile, and I'm like, okay, okay, crocodile, infrared, you can't see it. A crocodile is like, what? I'm like, oh, you're a crocodile. Oh,
Mhm.
specify. Infrared is invisible to human beings, all right? But then, even now, there are some human beings that can see infrared, because they have these eye defects.
Oh, okay.
So let's specify it even more. Uh, Infrared is invisible to the majority of the human population. If you can see infrared, you're among the 0.0000001%, because that is the estimate, like there's 1 in 7 billion. So if you have it, you're one of only 3 people in the whole world.
Mhm. So once again, like, I think that is why in the beginning I was like, and that's the trend I usually see. That's why I try to trade it, that we human beings, we try to, especially in epistemology, we try to narrow down things to instances. Like, I cannot see infrared. I think because of the same reason that the nature of reality is so complex to discuss, that every single time you will try to discuss the question of epistemology, you will be gravitated towards the question of nature of reality.
Simplify.
So we need to be more instantaneous with that. I think the shirt incident, I have been thinking about that, and it reminds me. So this is a sort of a common thing in epistemology. One of the criticisms to the definition of epistemology, because so far we said that the definition of epistemology is justified true belief. So I make a claim, I believe that claim is true, and that so for it to be knowledge, it has to have a truth value, right? It has to have a truth value, and that truth value is that it's true or it's false. But if it is false, then it's not knowledge, it's not a fact, right? But if it's true, it's a fact. So one of the criticisms to this idea about belief, claim, truth value, and justification was given by one of the philosophers. And we cannot talk about the nature of epistemology without talking about Edmund Gettier. So Edmund Gettier, he had this idea, what was later known as the Gettier case. He says, okay, for example, you make a claim that let's see, I want to make an example. There have been so many mm, outdated examples that I don't want to give anymore, but okay, let's go for the sake of simplicity. One example that I think philosophers often give is that you're walking through you on a highway, and you see a farm. You see a farm, and you see that it has, like a barn. It has that exterior, but in reality it's a film set. It's not really a barn. It has nothing behind it. Okay. A more modern example, you see the Matrix trilogy, not the trilogy, the fourth one. You see the trailer of that, and it's like, uh is this Keanu Reeves real or not? Is it, so you say, okay, I think, I believe this Keanu Reeves that I'm seeing right now on the screen is real. It's not the AI version, right? It's not the virtual reality version. You say that, and it just happens to be that it is true that he is the real Reeves, right? But because of your belief that because the idea is that somebody's trying to convince you that, oh, these are virtual reality ones, and you say, no, 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 these are real. So you get me, because there's a new example that I'm trying to construct, because I didn't want to go with the barn example that people usually use. So there's a lot of Keanu Reeves on the screen, right? And somebody's like, oh, these are, they are created by the AI software and everything, and you're like, no, that's real. And then you pick one of them and you zoom on it, and it's actually the real one. So by luck, you have lucked yourself into the real one. So what is happening right now is that your claim was that these Keanu Reeves on the screen are real, and that is my claim, and my belief is that they are real, right? And I have a justification that I zoomed in and it turned out to be real. So now, for me, the statement of my belief that these Keanu Reeves on the screen are real turns out to be true. But in reality, I just lucked, that the only one of them was true. Similar to, I think, like what happened with, let's say, Newton. He talked about the laws of nature, and how the forces work. And it just happens to be that they all the time they work. But there are exceptions, like the heavenly bodies. There are exceptions, right? But what if you pick one heavenly body that just happens to be, and I'm giving an extrapolated example, just happens to follow the laws? Would that make the universal law of Einstein wrong? So I think it's a difficult to
Again,
follow example.
I think, okay, for example, right, if you talk about the physics example, um, you talk about if one instance of it being false, does it mean the entire thing is false? It depends. Is it repeatable? Can you repeat that anomaly, or is it just an anomaly? In fact, I think in 2014 or 2012, they actually did a study of I think they blasted a bunch of neutrinos, or these particles. And what they noticed is that these particles arrive at the destination faster than speed of light. And the entire physics community went crazy. I'm like, oh my God, Einstein's theory was wrong. Oh my God, this can change everything. Oh my God, everyone's panicking. Like, oh, right. Like, could this be true? And then they repeat the experiment. It never happened again. And they did an investigation. And apparently, it's a calibration error.
Okay.
Meaning that the theory is still true, but in that instance, when it was, like people were panicking. People were panicking because there's one of two possibilities. Number one is that Einstein was wrong. Number two was that, there's an error. But there's this huge possibility that Einstein was wrong. So how do you counter that? You do the experiment again. You repeat it. Can you repeat the experiment? Again, it comes down to consistency. What if the thing that you're experiencing as truth is an anomaly? And the only way to do that is to repeat that thing as many times as possible. I think if you have a high sample rate, just have a high sample rate. That will fix the issue. Why are we going further? Why not just have a high sample rate? Isn't that enough to justify the truth? What do you think about that?
See, here's the thing. This is why I tried to make a distinction in the very beginning. Philosophy does not care about scientific experiments, right? So, and the reason I am saying this is because we are talking about maybe we can talk about virtues that are impossible to actually take a scientific experiment, right? So like maybe religion or belief or superstition. So for example, somebody believes that, okay, this is the example that Edmund Gettier gives himself. This is the example, the guy who creates this Gettier case gives, and it's a weird example. I don't like it. That's why I didn't want to give it, but let's give it a chance. He says there are two people, they go for the interview, say Salman and Nabil. We both go for an interview, and I have 10 coins in my pocket. You have 10 coins in your pocket. Just happens to be that we both have the same amount of coins in our pocket. Now, when we are doing the interview, we both do our interview, we come out, and then you go meet the CEO of the company, right? And the CEO, you ask, in a hinting language, so who's gonna get the job? What do you think? You ask him, and he says that I think Salman will get the job. Not I think, he says Salman will get the job, right? So later we are sitting down, and I take my wallet out, and you happen to see that I have 10 coins. Okay, you happen to see that I have 10 coins. Now, based on the knowledge that you have, you can make a claim that the person who has 10 coins in his pocket will get the job. Okay.
Okay.
That's what they use, right? That's what they use. That's why I didn't want to use this example. It's like no correlation. What does coins have to do with job? But but this is the claim that you come up with. Now the thing is that you have a preposition, you have a claim, right? And you form go on.
Okay.
And you form a belief on that the person who has 10 coins in the pocket will get the job, right?
Okay.
And then the thing is that you have a solid justification for that reason, that why do you think that the person who will get the job has 10 coins? Because I saw 10 coins in the pocket. The CEO told this person will get the job. This person has 10 coins in the pocket. Makes sense? But here's where he complicates it way beyond I don't like this example, but here's where he complicates it. It just happens that at the last moment, the company decides to change their decision. And instead of me, they give you the job. Okay. And you're like, wow. And you're so happy, and you want to get a Starbucks, and you take out your wallet, and it just happens to be that you have 10 coins in your pocket. So the person who gets the job has 10 coins in his pocket. It has, he has a good justification for his belief. See, the point being, I think, because you are too rational for abstract philosophy, you always gravitate back towards experiments. And I respect that. But the idea here is that the philosophical idea of epistemology is justified true belief. So you have a belief, and it's not supposed to be justified true belief. It's supposed to be a justified belief, which is true. But just because of how English language works, we say justified true belief. So basically, you have a belief that is justified, and that happens to be true in one instance. So you have a belief that the person who has 10 coins in his pocket will get the job. How is it justified? Because you saw the person CEO saying that this person will get the job. You checked that this person has 10 coins. It's a justified belief, and it just happens to be true. So, it's still not a fact. The person who has 10 coins has nothing to do with the person who gets the job. It's still not a fact. So this is where Gettier uh, tries to combat and argue that facts and knowledge are not based on belief or justified belief, but the truth value has nothing to do with either belief or justification of belief. But once again, the justification of belief remains a core component in trying to find the truth value. I actually do like your argument that just repeat it. Just try to see once again, ask other people if they got the job and they had 10 coins. I actually do like that argument. It's just that maybe we're not, uh, it's just that once again, if it's a law, it has to work every single time. I think that's how I see it.
Yeah, I think when you mentioned that, there's this joke by Norman McDonald. I don't know if you know him. He's a comedian. The joke is like this. Is a bit lengthy, but let me tell you the joke. One day, okay, so me, right? Imagine one day I'm walking into a new neighborhood, and one day, I go to the cafe, and I see this guy in the cafe. He, I've never seen him. I want to make new friends, and I go to him and I ask, hey, my name is Nabil. What's your name? My name is let's see, Shahu. My name is Shahu. All right. And then and I'm like, oh yeah, Shahu. What do you work as? And then Shahu's like, yeah, I'm a professor of logic. I'm like, what? Professor of logic? Well, what's professor of logic? What is that? And he's like, Shahu's like, okay, let me give you a demonstration. Do you have a dog? I'm like, yeah, I have a dog. Yeah. And he's like, if you have a dog, that means you have a dog house. I'm like, oh yeah, I have a dog house. And then he's like, oh, if you have a dog house, then that means that you have kids, because like kids play around dog houses. I'm like, yeah, I have kids. That's true. And he's like, oh, if you have kids, then you must have a wife. And I'm like, oh yeah, that's true. I have a wife. And then he said, if you have a wife, that means that you're a straight man. And I'm like, oh yeah, that's true. And then he's like, oh yeah, that's what I do. Yeah, that's logic right there. I'm a professor of logic. I'm like, oh yeah, just by having like all these assumptions, then this guy can know whatever the hell I'm doing in my life. Can know all my properties.
Like
So
Sherlock Holmes.
Like Sherlock Holmes. So at night I went to the bar, and I saw this. I saw my old friend. His name is Salman. And Salman is like, hey, Nabil, like anything interesting happened today? And I'm like, oh yeah, like this morning I saw this man. This man he works as a professor of logic. And I'm like, what the hell is a professor of logic? And I'm like, okay, let me demonstrate to you. Okay, so Salman, do you own a dog? And you're like, no. And I'm like, so that means you're gay.
Okay. Yeah, I think I've heard that before. It's good. But see, that is the thing, right? With logic, that it's so unpredictable. And I think if I have to actually connect this to my topic, I would once again argue that. Now, I don't want to dissect a joke, okay? I don't want to dissect a joke, but I do want to talk about logic in general, since you have you have brought this up, right? So the thing is that when you talk about logic and you talk about building from one thing to other, uh, and I understand that maybe that is the gist that you were getting from this conversation about epistemology in general, that uh, for beliefs, two events just have to collide, right? The thing is, in epistemology, it does not have to be a universal belief. It has to be one statement, and that statement has to be a fact, but that fact has to be based on a belief. The problem is, so if and this is coming from logical aspect, right? That for me to have a belief, I will act on basis of that belief, right? And this is the belief component, and this is the fact component. So for something to be knowledge, I need to have a belief that, oh, if I go somewhere, if I let's take the barn example. All right, I'm using all these examples that are not working. Let's use the barn example. So you're driving by the highway and you see a barn, but that's not an actual barn. It's just fake, it's cardboard. And there are so many fake barns all over the street, all over the highway, right? But you don't know they are fake, right? You don't know. So you point at one barn and you say, this is a barn. Okay. So now you make a claim based on the belief that you are convinced that this is a barn, right? This is your belief. And this is the truth. And you it's a hidden card. We don't know. And when you open it, it is a barn. The point is that epistemology generally, and the way human beings also generally think, is that if the belief is supported by the fact, then the belief is true, right? If the belief is supported by the fact, the belief is true. So if I do some weird, oh, every time I don't bring my umbrella, it rains. Simple example. Every time I don't bring my umbrella, it rains. So the belief is, if I don't bring my umbrella, it rains. But if I actually don't bring my umbrella and it actually rains, it's actually a fact. Even though they do not have a direct correlation, but they both, for both of them to exist even as what you would call coincidence, that would make a lot of problems for our general understanding of how logic and knowledge works. That the belief is wrong, but the fact is true. So maybe once again, to counter your argument about repetition, the point is, if it's a law, if it's a rule, so in comparison to a belief, you will have to introduce a new belief, right? So for you to say that every time I don't bring my umbrella, it rains, somebody will have to say your umbrella has, no, it's not true. For somebody to decline your belief that umbrella, if I don't bring my umbrella, it rains, you will have to say, no, it doesn't matter, right? Or something that the exact opposite statement would be, even if you bring your umbrella, it will rain, right? That will be the exact opposite statement. But the thing is, that is a belief, because experiment has not been conducted yet. And for that belief to have a truth value of yes or no, you will have to conduct an experiment. And
exactly.
So when you're talking about, and it just hit me actually, one of the most important points is that when you talk about experimental repetitions, you talk about something that is, well, the experiment was not done good the first time. There were anomalies and there were, things that were not accurate or calibrated properly, right? But in this case, that's not the case. It's not an apparatus fault or a human error. You're just experimenting it in isolation, right? So those things don't matter. This is why repeating it will not matter. But the thing is that for it to be a belief, it must be universal. So for my belief that if I don't bring my umbrella, it will rain, for this to be true, it only has to rain once when I don't bring my umbrella. Do you get me?
Yep.
But
In that instant,
no, just once, because a belief is something that is universal. But for it to be a fact, it just has to happen once. At least that's the way I understand it. But for the belief that, oh, even if you don't bring your umbrella, it will rain. It also just has to happen once. But what if it don't? What if I bring my umbrella and it doesn't rain? And what if I don't bring my umbrella and it rains? The fact is true. The fact that you didn't bring umbrella, it rained, is true. But the belief is still wrong. You get me? You know what? Let's demonstrate it in a more
The belief
more
is. Mm,
let's do it in a more exaggerated way. You say repetition. I try it 1,000 times. Every single day I don't bring my umbrella, it rains. I don't bring it once entire week, it rains every single day of that week.
I have super bad luck.
But you cannot rationalize bad luck. The thing is that we know that this belief is wrong, right? Would you believe that you know what, I'll give you an example from my real life. This is true. I'm not making this up, this is true.
Mm,
So every time I have back when I used to have the old MacBook, I used to bring my charger with me. I used to look at my timetable and I'd be like, is it a long day? Do I need my charger? Is it a long
mm,
day? Yes, I bring my charger along. Sometimes I'm like, it's a short day, I leave my charger. In that exact day, either we get an extra class, or we just have to stay for some activity after school,
mm.
basically. And it has happened every single time I forgot my charger at home, or
Okay.
just we do some CPU intensive tasks and my battery runs out. So
Okay.
my
Okay.
belief has formed that the day I need to stay till 5, the day I leave my charger at home, I will need to stay at 5. That's the belief. And even though, okay, first off, would you say that belief is true?
If I leave my charger at home, I'll stay at 5.
I will have to stay at 5.
5 is considered late,
Yeah,
right?
for
5
example, like,
have
for
extra
example,
classes,
yeah,
right?
for example, like it ends at 2 or something, and 5 is late. So, okay,
Uh,
simply, if I leave my charger at home, I will have to stay late. Do
if
you
you
think
leave
that
at
belief
charger
is
at home,
true?
I don't believe it's true. I don't
You
believe it's
don't,
true.
you're like, that's absurd, right?
Yeah.
But the thing is, if I do it, if I leave my charger at home and I get to stay late, and for the sake of your argument, I do it twice, thrice, 5, 10 times, every single time it happens, right? So would you still change your belief? You'll be like, no, it's still absurd. Your argument would be, that's a coincidence, that's a massive coincidence, right? But
Okay.
that's the question. Why? If you say that you're a man of logic and experiments can change your belief, do they get the core of the idea,
All right.
right?
All right. All right.
That
All right.
some ideas we reject as ridiculous there and then. Why is that?
Yeah. Yeah. I'm not going to reject it, right? I'll be like, at the beginning, let me be hyper specific. Okay.
Okay.
Salman, the probability that your belief
Mm-hmm.
is true, I believe is unlikely.
Okay.
Unlikely. The probability is very low, right?
Mm-hmm.
Probability that every time you bring, every time you leave your charger, there'll be an extra class that you'll be in bad luck. The probability of that happening is extremely low,
Okay.
right? I suggest do, more, even more samples. Do it within an entire year. Do it within an entire year. If it's still consistent, if you consistently, like every time you leave your charger at home, there'll be an extra class. And amazingly, for the entire year, like the teacher is like, there'll be an extra class. Either two possibilities. Number one is that you are included in this super small probability. You have bad freaking luck that you're like, oh, you're like, or
Okay.
there has to be an underlying cause. There has to
Okay.
be an underlying, maybe, okay, another scenario. I have to now I have to put in other scenarios, like, okay, but that scenario is so low. There has to be something going on. Maybe your teacher stalks you. Maybe maybe your teacher's like, every morning I have binoculars. I zoom at Salman's apartment, and every time he leaves the charger, I really hate him. and I really want to make sure he suffers. All right. He's not very instructor. Oh yeah, right.
Mhm.
Which probability is higher? I don't know. But at the moment, I'm like, Saman, I don't know, but here are all the possibilities. Which
No,
one is
let me
true?
ask you
Yeah,
something.
I don't know. Okay.
Let me ask you something. Why is it that you need an underlying cause? Why can't it be a direct correlation? Why do you need an underlying cause?
Why do I need, and like, for example, right? What if your teacher hates you? You mean that underlying
Yeah,
cause?
no, why do you need that cause? Why can't it just be that there is a relationship? It just happens, like why do you need a scientific or some kind of explanation for it to happen?
Oh, because then it opens the layer of possibilities, right? If if you doing that, what is that? Is that black magic? Is it, what is that? What, yeah, what is the mechanics that cause? I find that very interesting. What is the mechanics that allow you to, do that? At
Mhm.
the same, it's pure. Fine. One of the mechanics is pure coincidence. I accept that, right? Another mechanic is your teacher is stalking you and your teacher secretly hates you. I accept that mechanic. Another mechanic is there's black magic. Black magic exists, and like it happens once in a while. One student from your class is so jealous of your grades, and at the corner he's like while you're studying on your MacBook, that student's like, oh yeah, I'm like, well, okay, that's so interesting, right? What's the mechanics? And if it can happen to you, can it happen to anyone else?
Okay, I love this argument. I love this argument. It reminds me Aristotle in his very famous work on metaphysics. The very first line he writes, Aristotle, he writes, all men by desire, all men by nature desire knowledge, right? So
Yep.
something about that, we cannot just accept things to happen. Like, yeah, it happens. No, we need a reason. Like, why does this happen? So something about that we need a reason for everything to happen is really what makes it interesting. But once again, science has made it very obvious, and I can see how dominant science is that you need experimentation and repetition and average and everything, like for it to be an actual correlation between these two, right? But the thing is, this is where what we call the knowledge debate gives birth, right? So there are two schools of thoughts on this idea, right, which you presented. That's the idea of empiricism. So empiricism is the school that we need to understand, or the only way we can understand things is by sensory input, right? So you're like, there has to be a reason, right? So something has to relate, and something has to work, and things like that. There has to be an empirical reason for things to actually work, right? So for example, let's take an example of gravity. So we are like, Newton is like, oh, everything is going down. Why? There has to be a reason. It's like, we just accepted, like, yeah, everything is going down. But Newton was like, why is it going down? Why does it not go up? Why does it not stay? So then he found out reasons, like, okay, there is a force, it attracts and it goes down, right? So
Hmm.
we need a reason, and there's a difference. The other school is called rationalism. So rationalism is basically what I discussed earlier, deduction, that if this, then that, right? Rationalism does not need a concrete reason in the language of science. It can work with
Mm-hmm.
deduction. So mathematics is a huge example of logic and rationality, right? So for 2 plus 2 be equal to 4, you cannot empirically prove it. You just cannot. For me, you can be like, look, two pencils, I add two more, it's four. But that's still a demonstration, right? And I have to accept that this is one, this is two, and this is three, and this is four. What if I say I don't accept that? So the idea being the rational school reduces everything based on deductions, and these are obviously oversimplifications of how the schools work. But the empirical reason is like, everything is an extension of our senses. So the five senses we have, and we see science specifically following in this footstep. So everything, microscope is an extension of our eyes. Telescope is an extension of our eyes. All these auditory devices, all these screens, microphones, everything, it's an extension of our senses. And that's how we have been working for so long. But coming back to my idea about what is the correlation between belief and this is a field that will really be interesting in metaphysical and religious ideologies, the doctrine itself, that what if I believe in something and it is a fact, but you cannot find any either empirical or at best rational reasoning? Would you still accept it as fact, or would you not accept it as fact? You cannot find any correlation between them scientifically. Let's just stick to scientifically. Would you still accept it as a fact, or would you be like, no, I will not accept?
Let's take a step back. What is a fact? A fact, is it, okay, you're a computer specialist or a student, right? A fact is it like, if this is true, this happens. So Jack Jack will eat a burger. Okay. Jack puts burger in his mouth. Conditions for eating a burger is true. Jack is eating a burger. That is true. Is that a fact? A fact is basically something that happens.
Depends on which school you are referring to. So like I said, for empirical school, for empiricism, it has to have a scientific reasoning, which is basically an extension of our reasoning. So for empirical schools, Jack is eating a burger must be Jack. Okay, let's take one example. Jack ate a burger. How do we prove this is a fact? I saw Jack eating a burger. So an extension of my sense proved it. So like you refer to testimony being. So one way to prove facts is an extension of our senses. The other is rationalism. So there was a burger in front of Jack. It's not there anymore. And there was a burger in front of Jack. He picked it up. He took a bite out of it. He chewed it. So these are all different facts. And regardless of their scientific reasonings, we will say that he ate it. Do you get me? Like it's a different approach to prove fact.
Okay, I'm assuming that there is an alternative method to prove fact than scientifically.
Yeah.
Right? There's an alternative to science. Okay, now this boggles me. This boggles me because
this is new. Okay.
I think things very scientifically. So you're saying there is a non-scientific way to prove that things are true?
Okay, how do you define scientific?
Scientific. Okay, let's look at the scientific method, right? You see things and you can repeat it and it produces the same result. Okay, scientific method is like, okay, you have a hypothesis, you can prove it, right? Or scientific is you can repeat it and it consistently produces the same results. Hence, that is true.
I will not agree that is strictly speaking the definition of scientific. Repetition. What I understand is that science means an extension of our sense once again. So if I can see it, if I can hear it, if I can taste it, and I can smell it, it exists. If not, it does not exist.
Are you?
Give me an example and I'll tell you how it's an extension of our senses.
I'm blind. I'm deaf. I cannot. I don't have any skin.
Okay.
But someone sat me on the chair. I don't have any skin. Okay. Someone sat me in the chair and someone spins me really fast, and now I feel dizzy.
Okay.
How do I know if I'm dizzy?
What is that example? I asked you for an example of a scientific phenomena.
Scientific phenomena? Oh, okay.
Okay, Earth is flat. or microorganisms exist?
Okay,
I
let's
think this is a
say,
good example.
okay.
How do you prove microorganisms exist?
Okay, you can look at it under a microscope.
So it's an extension of our eye sense of
Hmm.
seeing.
Uh, what about what about mass? What about mass?
So here's the thing, right? Here's where the lines between the empiricism and rationality differ and blur. And this is why we often criticize science that you do not have proofs for certain things and you just make assumptions. So I can demonstrate gravity, right? I can demonstrate it will be
Yep,
here,
yep,
but
yep,
it will go down. This is,
yep.
even though this is testimony through our science of sight, that gravity exists. I am seeing that object going down. This is enough for the empirical school to say that gravity exists.
Okay.
Do you get me? And
Yeah.
then we can say, oh, we set timer, we set scale, and we saw it decelerate or accelerate downwards at a certain speed. So the force of gravity is 9.8. How do you know? Because I saw it going down at that speed. Do you get me? So because these are our main input, sensory inputs. So all these understandings are basically fed through these inputs. However, in comparison, there is rationality, which is like, okay, so this galaxy is this far away, and the universe is expanding at this meter per second or light years, then the universe must be this years old. One way you
Mm,
can differentiate between science or empiricism and rationality is that science is, let's just say, more confident. This exists, science. But rationality is like, if this, then this must be true. So if the object is going down, there must be a force pulling it downwards.
mm.
So this is at least how I would say philosophers differentiate between these two different understandings. So which one do you incline towards when you say something is a fact?
I'm having trouble wrapping my head around the definition of science. You know,
Okay.
is it an extension of our senses? If I do calculation in maths, what sense is that?
Rationality. That's why I said you cannot prove. How can you prove that 2 plus 2 is equal to 4?
How can I prove that the unknown element that
Mhm.
I haven't discovered will have the properties? What is that? I use my calculations and I know the
Yeah, but
exact
no.
property. What is that?
But but we
Isn't that
don't.
science?
Okay, here's the thing. And now this is something people disagree on, right? But I think exactly why, because it crumbles or at least shakes the foundation of that science has created. So we deduced that atom exists. We as in humans, the Greeks several millennia ago, they did this is a very famous experiment. Maybe it's called the air mill or something, but they did some kind of experiment that produced a pattern of air, you know, that proved that, oh, if air is traveling in this way, then it must mean that air is made up of smaller particles. So we deduced it, rationality. Okay. Now, along the line, we accepted. So this is called, I think, the Greek theory of uh, kaitos or something. It's that's the where the word kinetic theory comes from. I forgot what's the word. But along the line, so we use this word that atom must exist. Everything must be divisible into a smaller scale. Must. Along the line, somewhere we invented super electronic microscopes. We zoomed in and we saw atom. Now we are like, atom exists, not must exist. It exists. So this is how I differentiate. Broadly speaking, science does not differentiate like that. They think that logic and math is also in the same category. But if we actually look at from the lens of philosophy, it is not the case. So a lot of our experiments, like the famous Archimedean experiment about how things float, it's all just deductions, right? That, oh, if this much mass floats with this much surface area, then that means proportionally speaking, this much mass with this much surface area must float. So you experiment to prove that it's working, but you don't know why is that working unless centuries later you discover that, oh, water is made up of particles and this and that. So I think that's how I differentiate between science and rationality.
I mean, in my mind, when you explain all that, all I can hear is like science. All I can hear is science. Because, I think knowledge is based on, when we talk about knowledge, right, we look at the quality of the knowledge. Knowledge is built upon the foundations of a stronger foundation of knowledge. For example, let's say can I take a man to the moon? I have to rely on the knowledge of mass and force. Are these knowledge of mass and force reliable? I've done so many tests on it on so many different conditions, and so far it's been reliable. And I've counted all the anomalies, and I've calculated the weather, all that stuff. So far it's reliable. So I require all that reliable stuff. And when we say when we make the claim, Salman ate the burger, or the burger is gone because therefore Salman ate it, right?
Mm-hmm.
Even statement alone, the burger is gone, therefore the statement ate it. There's already different layers of the knowledge, because the burger is gone is a greater reliability of knowledge than the other one, right? Because the burger is gone, I can see it, I can prove it, I can look around.
Mm-hmm.
Therefore,
Mm-hmm.
one ate it. Even this itself, it relies on blah 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 blah. Is the burger really gone? Did someone took the burger, or did the burger burn in thin air, or was the burger hallucination? Like I was doing drugs. There's no burger. But this is stronger than that, and if you build on that, it becomes really shaky. And as you build, if something at the bottom didn't match up, the whole thing will collapse. But so far, what we've seen in science is that they've built in these strong foundations that even if this one doesn't work out, there are ways to go around it that makes it even more solid. That's why, for example, like the black hole, we have never seen a black hole, but we know the properties. We know how it looked like. The movie Interstellar produced an image of a black hole years before we actually see an image of a black hole. How is that possible? It's because of these solid foundations.
See, luckily for you, you're not the only one who asks these ridiculous questions. Philosophers have actually talked about this exact scenario. So, for example, like this is the work of what we later knew as the Enlightenment, about questioning knowledge itself. So these are the works of David Hume and then later Immanuel Kant, and they talk about a priori knowledge and a posteriori knowledge. So, and this is very important. And sometimes I'm surprised by how the questions that a daily, layman of logic asks, and science and philosophers of logic, come on. But philosophers have tackled them very precisely. Sometimes it's really interesting, and it connects back to the fact that philosophers are actually just answering the questions that we all ask silently, but do not have the courage to voice out because they are too ridiculous. But yes, Immanuel Kant actually does question these. He has a very beautiful work, Critique of Pure Reason. So he says pure reason, what you call reason, he criticizes how pure reason works. So if you sit down with Kant and you say that, how do you prove that Jack ate that burger? His question will be, how do you prove there was a burger? So
Mm,
so the thing
mm,
is, we he divides knowledge into two categories: a priori and a posteriori, right? So the priori is knowledge attained by, let's just say, external factors. So how do you know there was a burger? So I know what a burger looks like. I have seen it on TV. I've ordered many times. I've said that, oh, I need a burger, and I get a burger, right? This is priori, like that knowledge, not because of your direct first-hand experience, but knowledge because of external sources. This is priori. And then there is posteriori, which is knowledge based on your first-hand experience. How do you know this is a burger? Because I held it and I know that, oh, this resembles burger. But then there is the greater conversation of, how do you know that this is burger? So some kind of priori is always required for posteriori. So that is something for a dedicated episode on the critique of pure reason. But the gist and what is related for us here is that David Hume especially, he argues that for knowledge, and this is similar to the argument you made earlier, for knowledge to be rationally deducible, like you said, when you're deducing that the burger is gone, hence Jack ate it, there might actually be several different layers, like, okay, there was not a burger and I was hallucinating, things like that. He basically says, for knowledge to be deducible or to be usable at all, first off, it must be, let's just say, consistent. That is the most oversimplified version. It must be consistent, and that is the argument you made earlier, right? And the thing is that in this regard, science and rationality are not too far apart. So even when you talk about scientific discoveries, about we have not seen a black hole, but we know what a black hole looks like, and we can render it without actually getting a picture of the black hole. When you say all this, there is an underlying assumption that all our corrections, all our calculations, and all our assumptions so far are correct. So your idea of building up on logic, at least, it is something that is true for both empiricism and for rationality. In both, we build up on knowledge that is consistent and complements each other. Like, for example, I said, if tomorrow we find out, like, let's simplify it in this way: everything we know about science, we know through science, is a assumption. Would you agree on that? Or
yeah, yeah, yeah.
even
Uh,
though when we have scientific experiments?
it is um, to maximize certainty and to minimize uncertainty, right?
True, but at the end of the day, it remains an assumption.
Yeah, at the end of the day, it remains an assumption, but a very highly thought of, highly useful assumption. Okay, maybe it doesn't have to be useful, but maybe it has gone through, like, here's an assumption. There's bad assumptions and there's good assumptions. Bad assumption, onion under the chair, it will cucumber it. Good assumption, a vaccine that have been tested for years. We have tested it for millions of people, bulletproof. So take two assumptions, shoot at it with so many bad assumption, not bulletproof. Good
But
assumption,
once
bulletproof.
again, the example that you're taking is once again more towards the side of senses. So we have seen that, oh, vaccine goes into the body, and this person was immune before, was not immune before, now he's immune. So it all connects back to senses. I want to focus more so we can actually highlight the question. Would you say that um, scientific discoveries that do not have any visual or sensory, any sort of sensory uh, proof, are still scientific discoveries, or still scientifically accurate? So, for example, gravity, or for example, the tides of the moon, we cannot see them. We cannot see them. So we build on rationality, like, okay, the moon has a gravitational pull, and the water, that maybe it's causing the tides, you know so somewhere, uh, even scientific discovery with all its extent, and this is the unfortunate trend that science has taken in the past few centuries. It has relied so much and so much on the empirical school of thought, on the understanding that every single fact, every single thing that is true must be able to be experienced through our sensory inputs. That has been the underlying assumption that science has worked with for several centuries. And because of that, we suffer on the rationality part of the school, that, for example, if I talk about a lot of things in logic and philosophy, like the knowledge argument, they were not, let's say, pursued as other scientific ideas were. So we created a sort of a world that talks only about experiments and repeating that experiments, like you mentioned, and anything that passes that filter of experiments, and at the end of the day can be experienced through my senses firsthand, is what remains true. But you see that when you talk about epistemology and you talk about the nature of knowledge, we know that that is far from truth. Our entire understanding of the existence of the universe, to mathematics, to geography, for a good long part of the world, remained on deductions and reasoning that to this day cannot be received and proved through our sensory inputs. So that's just some food for soul, that maybe the scientific school has to rely more on rationality rather than experiments.
Okay, here's what I noticed, right? Number one is that when we assume that something is true, one of the things that I noticed from this conversation is that it relies on a sort of rules. It's true in what condition? It's true assuming what? What are the conditions? And this led me to, for example, right, or did someone eat the burger, right? Now let's assume, let's confirm, assuming a burger is this specific arrangement of molecules that constitutes bread, meat, and assuming a salmon is not this fish, right? It's a human being with a long beard and combs his hair, like with a with whatever that is, right? And
I'm
sleeps
sorry
only
you
for
don't have a beard.
right. Let's assume that is a salmon, right? Assuming that is true, then what is
Yes.
what is there to be proved? Okay, now we move on to some like mathematics. Mathematics are like this. In fact, the reason why I was smiling is because there is like this, I think, friendly competition between the field of mathematics and the field of physicists, right? Physicists are more closely related to scientists, in which they want things to be true. They want things, as you said, senses, right? Maths, they they love to be useless. This is not from me, okay? This is from Michio Kaku. In fact, mathematicians love it when they're useless. They'll be so proud of like coming up with useless things. They'll be so proud. Sometimes physicists are ahead, in which they're like, what is this? What is this phenomenon on the sky? I cannot prove it. Mathematicians, right? You can't solve this problem, right? I'm ahead of you. Sometimes mathematicians are in the way. You're like, here's unreal numbers, right? Here's like all these, you can't use this, right? Completely useless, right? I'm ahead of you. A good instance is like this. A physicist would come to a mathematician and would say, how many, I want, I found this particle. What is the area of the particle? And then the physicist is like, okay, how many, do you know, does it depend on the number of sides of the shape? And a physicist would say, okay, just take this particle, like use it in the scanner, and like that's how you guarantee the shape. A mathematician would be like, what is the number of side of the polygon? All right. Okay. The number of side. There's a calculation of the number of side of a polygon. I forgot what's the equation. Like A-level physics or mathematics or something. So polygon n is equal to blah blah blah. Something along the lines. So it's like just give me, okay, here's the equation. Just put your number here and it will work out, right? Here's the mathematics. Here's how it will be useful. Okay, I'm bad at explaining the story, but the main basics is, it's like mathematicians are in their own world. They're like, oh, my number matches out. Oh, imaginary numbers, whatever the hell that is, right? You think that infinity is the biggest number, but you might be surprised that there are some infinities that are bigger than other infinities. What the hell does that mean? I don't know, but I'm a mathematician. It all matches out. Ooh. But the main thing is all the same. A mathematician is proud of proving things if it's within that statement. Like, here's the situation. How would you prove whatever it is in that situation, right? We see physicists like writing mathematics. They're so carried away by empiricism or whatever, right? They're in their own world, and things are true in their own world. I'm not sure if this getting too carried away. Let me know. But
No,
I think it's just,
I get it. No, it's actually right on track, because
that's it. Yeah.
see, what I notice immediately is that there are two different points here. Okay, first off, so you talked about this race between maths and physics, right? And I think it's right up on track, because it's the same frustration that I have with the world of science in general, coming from the world of philosophy, where philosophy relies so much more on rationality, right? But science relies so much more on sensory input. And this is the kind of the battle that we have been going on for so long. And this is, if you actually track it down, this is like in the times of the Greeks, this is where science and philosophy are parted, because philosophy was like, there is a world, there is a realm beyond your sensory inputs. But science was like, well, that's useless world to me, right? I haven't got nothing to do with that. I need something that I can create inventions out of. So that's where science and philosophy parted so long ago. And it's really interesting to see that mathematics remains in the middle of both, right? So there is logic and formal logic, what we call formal, and other attributes of mathematics that we use in philosophy. And then obviously heavily mathematics is used in physics. So I think mathematics remains in the middle. The idea at the center remaining that all the mathematical components or the mathematical ideas, you cannot prove them with your sensory input. They
Exactly.
have nothing to do with your sensory input. The second very important point that I notice is that, at the end of the day, even physics or all other sciences that take great pride in their understandings and demonstrations of their ideas through visual or sensory experiments and sensory demonstrations, at the end of the day, they also take refuge in the world of logic, which cannot be further reduced down to sensory input. So they're like, okay, there's a moon, or let's say there's this earth, and there is the sun, and we can see this from telescope, and we have set artificial satellites outside that have noticed that the earth actually rotates around the sun. But at the end of the day, they're like, so how many days does it take? Oh, it takes 356 days. But 356, what's that? Prove it through your senses. And science is like, no, that's mathematics work. Do you get me, right? At the end of the day, even science, with all their understandings of sensory input and their emphasis on sensory input, at the end of the day, they also resort to mathematics and logic and deduction. So they start off with experiments. They're like, oh, this is, I can see that, I can observe that, and, I can prove that through experiments. But at the end of the day, when they are using mathematics, they are resorting to a rational idea that cannot be proven through sensory inputs. So I think that was really interesting to see that maybe these schools are not two opposing ideas, like the world of doctrine has seen for so long, and there has been this hostility towards the people of doctrine and the people of science who focus more on experiments, and the people of doctrine who focus more on logic itself. But maybe they are like building blocks of each other. So maybe you can start with exponential experiments and sensory understandings, but at the end of the day, it you reduce it to rational, which is not possible to prove or even experience through sensory input. So I think that was just a very interesting outlook in general about what we understand about the world is not binary. It's somewhere between. But that also brings us closer to the question that is mathematics can mathematics actually, let's just say, exist? Does it even exist? I can't help but think about it, because how do you prove that a number exists? How do you prove that 356 exists? What is 356? But I think we're getting really far away, and I would love to see that I love to go down that path, because these are more about the posteriori and the priori knowledge. So that is something for the critique of pure reason. I think what we understand as maths or numbers or countables and incountables, what are those? So I think that is something for another day. For now, this was epistemology and our understandings about epistemology. I believe this episode was all over the place, especially because of how broad this concept is. But
you know what? Okay, actually, I would love to continue this, but it's already late, so we have things to do tomorrow. But just something I noticed, it's like I'm interested to see where does philosophy or as you say the doctrine and science, where do they collide? Because that'll be interesting. For example, it's interesting to see where science, physics, and mathematics collide. Of course, there's separate fields. Sometimes if you see Venn diagrams like this, right? For example, one interesting part that we can explore in the future episodes.
By collide, do you mean conflict or overlap?
Overlap.
Okay.
And we can see how it differentiates. For example, like this, right? I'm not sure what you make of this instance, but in the future, self-driving cars are already around. And I think 5 years ago, there was this questionnaire online that I was attending. I think it was by MIT. And the question is like this: we already have self-driving cars. So here's an instance. Here's a trolley problem. The self car is moving, right? And there's a grandfather here, and there's a pregnant woman here. And it can only hit one or two. Which one should it hit? So I think this is an instance where it's so interesting, where like science and technology merges with philosophy. Suddenly
and this is extremely important. I remember that this was a thing back then. Yes, it was a good like a wild phenomena. And I think this is why it is extremely important for the scientific world to pay more attention towards doctrine or philosophy in general, because like I said in the beginning, philosophy deals heavily, rather the entire world of philosophy in one way or another revolves around virtue, or at least virtue or morality is something that philosophy cannot ignore at all. And because of how much science and corporations, let's just say, have mingled lately, because of that, science has lately been avoiding these questions of morality. Like, okay, here's my understanding: science does not care about morality. That's
neutral.
Just not
neutral.
Okay, neutral, yeah. But it doesn't care about morality in as a whole. It's not even a thing for it. It's not even an invention of science. It's if there was no philosophy, there would be no morality, I would argue, right? But the thing is, now that you have to present those scientific inventions into a world of moral beings, hence the questions of morality are given birth. But the reason they are so bizarre and everybody is clueless about that is because all this while, when the scientific discoveries and inventions were going on, we didn't care about morality. And now all of a sudden, we are like, who will this car hit? And I am afraid if science continues to go down this line, uh, we will produce a generation of human beings that will not be concerned with morality either. Because at the end of the day, there will be a human being sitting inside of that self-driving car. And the more and more we use these moral less technologies, we will become one with them. So I think this is why this is the peak tide where morality and philosophy should really, really interfere and tell science to change its direction towards virtue.
I like that. I like that. It's like this opens a whole new can of worms. I don't know. It's also like technology, right? Instagram for kids. Is it good? You know, it's using technology, it's using science, but is it good? Is it moral to show these kids pictures of, you know, like something that they've never seen before? Should Instagram be moral? Should you know, like capitalism, is it moral to like just squeeze Apple to squeeze out all these Chinese workers, sweatshops? Is it sweatshops? Yeah. Is it moral? I think
I think
that's a
Instagram is a prime example. And,
yeah.
it's a demonstration of what I just said, that for so long, since like 2007, Facebook, when 7 or 4, when Facebook came out, when social media came out, since then till now, you're just increasing the scientific the science behind social media. So algorithm, data learning, machine learning. And
Yep.
now suddenly, when it has reached its peak, now suddenly you're like, oh no, body imaging is a big problem for our society. But you're the one who created the algorithm that will promote the most ideal body figure. So it connects back to that. When science is growing unsupervised, unconcerned, and unbothered about virtue and morality, then this is evidently going to affect the society, and at the end of the day, the user of science. So I think this is really something that needs to be addressed in one way or another.
Mm. I think this is very, very interesting, and I think something that I don't think about. You know, of course, you know, in the ideal future, you know, we all should be working together, scientists, philosophers. You know, like trying to figure out what is the best way to operate the world. And I don't think it's a one field to rule them all. You know, I think it's a collaboration between all different fields, and I think the better we communicate with each other, and I think it
Yeah.
is important to have dialogues like these. Is that
Mhm.
me, it's like what, you know, I heard this joke from Ricky Gervais. The atomic bomb in Hiroshima, people say science gone wrong, science gone bad, they kill millions of people. No, actually, no, that's actually science gone right. Science gone wrong is this. That's science gone wrong. Science gone right. Why? Because
You
science
mean
is
the
a
science is working? It was just designed to be.
science is working, right?
Yeah,
The
yeah, yeah.
morality, but science is working. So science is neutral ground. Does it work or
You
it
know what's
doesn't
more
work? There.
interesting? It's really interesting that historically we have seen such civilizations. Usually you come across a period of time. I do not want to, specify it because it's broad and different for different geographical areas. But one key hint is, you come across some personalities, you Wikipedia them, and it says astronomer, geologist, physicist, scientist, mathematics,
Polymath.
polymath. Why? Because exactly like you mentioned, that there is no one field to rule them all. A lot of these fields must come together for a balance between scientific advancements and a balance between social advancements, keeping in mind how society has been made. It is daunting how scientists in their own lab have no idea how the real world works. And I mean, they know how to squeeze it to get the work done, but they do not know how to flourish a society as a society. This is why we see that all these latest ideas of digital technology, every 5 to 10 years after the product has been invented, they're trying to, they're trying to minimize the damage. They're like, okay, now let's create YouTube for kids. Okay, so we created these screens that destroyed your eyes for 10 years. Now introducing nightlight. You didn't know that when you were creating the screens in the first place. So something like that uh, science does not know what it's doing. It's just, this is my favorite example, in 2014 or something, Samsung created S7 Edge. Like, okay, we can bend the edge of the screen. Okay. Everybody was like, wow. 3 years later, I think it started with S6, S6, S7, S8. 3 years later, they're like,
That's
we
expressed.
can
Yeah.
bend the glass. But why do we need to bend the glass? Why does a phone need a curved edge? So I think from S9 or S10, they removed it. They're
Yeah.
back to flat. So something about the science just randomly just doing whatever it can, and it has no sense of direction. So,
No,
something
for
like that.
for that, yeah. Sorry, Salman. I just need to correct you.
Go
Uh,
ahead.
it had a sense of direction because it's motivated by money. In the
True,
mobile
true,
markets,
true.
everyone is competitive. Samsung and Apple especially. I need to get the latest. I need to get a unique selling point. Anything curved screen. Ooh.
Mhm.
Right now you see the same pattern. Flip phones. Is it really useful? I don't know, but it's gimmicky. It's unique. If you have it, you're among
Mhm.
the people. So it
Mhm.
was motivated by something.
But then
But
the
I
direction is arguably wrong.
arguably you can see, it's maybe more right, maybe more wrong. You know,
Mhm.
a wrong one, as evident, was when the Samsung Galaxy Note 7, right? That was wrong because they put an unsafe battery,
Mhm.
and
Mhm.
suddenly, like, it became Samsung's worst PR, because suddenly in every airport it says, if you have a Samsung Galaxy Note 7,
Yeah,
don't
yeah.
bring it here. It's a bomb, right? That's bad marketing for Samsung, like that. That's free bad marketing, right?
Yeah.
Where does it come from? Is it science? Or maybe it's just capitalism. Maybe it's a different field because they just want to put in as thin as possible, even if it's risky, put it in. I don't know. So I think maybe you're right. It's multi fields.
Yeah, but I
Maybe
think it connects back to the fact that, like you were saying, unique selling point. But do we need it? We don't. We didn't even know that was possible. We didn't even think, when you Google futuristic phone concepts, none of them are like curved screen or flip edges. The things that the companies are actually designing, nobody wanted that. So so something about that, the scientific inventions are not happening with the right direction, which is, they're supposed to be a benefit for the society. But if their target audience is, or if their target is just monopoly and money and marketing and capitalization, then that means that they will evidently and gradually be a bane for the society, like we have seen. But phones exploding, that is something we can all agree that, oh my god, it's a bane for society. But let's talk about, the banes that were, let's say, gradual, or the ones that even today they want us to believe that it's the new norm. The metaverse, nobody asked for it. Why is it a thing? But now they're trying to sell it as to us. You buy houses in it. You do virtual reality shows in it. Why? Nobody asked for it. Everybody's creeped out. Just today I was watching some, I don't know what was the name of that robot or something, like full humanoid size robot, uh speaking with natural language, Axa or something. So that was
I
the
don't know.
name. And everybody commented, who wants this? Why is this a thing? Delete this, burn this is not the right year. So I wonder why and how does a company go like, let's create a human robot despite all these philosophers. The idea that we discussed earlier about AI taking over, that actually comes from philosophy. Science is not that capable to measure its own problems. And that's why we see it has ignored it time to time and continued with creation of such AI and stuff. And even though my position on AI is generally very accepting, but uh, it must be a given that it should be under the philosophical idea of virtue. These are some thoughts to think about. And yeah, I think that is it for this episode. Uh, do you want to share anything further? We talked about
No,
epistemology. Talked about the nature of knowledge, the theory of knowledge. It was all over the place because of how I would say this is a pretty complex topic. It is a pretty complex topic. If we missed something, if we were wrong about something, feel free to add on.
no.
Nabil, would you like to add on?
My general idea is when I look at epistemology, I'm like, what the hell are these philosophers smoking, man? I'm like what something so simple. I mean, I'm looking it up and I'm like, what's like. I mean, there's some philosophers that I look up, and one of them is like this, like just look at like there's these people of different fields. I think from something that we didn't mention is skepticism, right? There's
Oh,
the
yes.
yeah there's I mean I don't mean to lengthen it, but Cartesian way. I just saw this Cartesian way, Russellian way, Moorian way. All of them have
Mhm.
different parties towards this. Cartesian is like I think, therefore I am. Whoa. Russellian is like there has to be like uh, like there has to be like a god figure or something, right? And then Maureen was like, what the hell are you guys smoking, man? Just look at your arms, right? It's true, right? Okay, don't think too much, that's it. So many different like arguments, and interesting to see these different personalities. But I think in the end, what I think it comes down to is that like it all boils down to this for me. Maybe it's the scientist in me, but it all boils down to this: is it useful? Is it useful? Because when I watch The Matrix, I'm like, oh, is this the real world? Oh, I don't know. I don't know. Like, should I just not do my job? Because maybe my job is not even real. Do I fear? Maybe my feelings are not even real. Makes me even more unproductive. What are my choices? Well, just move on, like there's nothing to think about it. So in the end, for me, as a layman, as a man of logic, how useful is it for me? Are these
I often say to people who question philosophy as a useful or useless device, I often, and this is usually their argument, that if I start questioning everything, I will become unproductive. And I tell them that if by any chance you find the answers to the solutions, you will become 10,000 times more productive. So it really depends on where you are in your journey of knowledge. And it's a given that philosophy is not for everyone. I do not recommend everybody to dive into philosophy, especially if you are in a volatile stage at your life. But I think in a more poetic sense, every once in a while, yeah, true, that's true.
I
I
agree
think
with that volatile sense.
what
Like
are you?
no, like there's I had a friend. I'm not sure if you've seen the movie uh like there's this movie that Soul. Have you seen Soul? It's about this person dies and he goes to the afterlife, and it's like, oh, like it's by Disney, actually, very interesting. Maybe you should look it up. Yeah. And I was telling my friend, wow, it's so interesting, like what if the afterlife is like this, oh, right. And then my friend's like, what? No. I'm depressed at my job, and I watch that and I'm even more depressed. I'm like, oh, okay, maybe it's not for you. Yeah,
Yeah,
I agree
no,
about that.
yeah. All fields are not for everybody, right? So I think yes, this is something even philosophers agree that if it will make you unproductive in one way or another. So do not dive into that in that sense. In other words, do not let the intellectuality or the intellectual works affect you in a personal way, if that makes sense. But honestly, here's where I think it was really important. Here's why I think philosophy changed its entire direction when epistemology was introduced. I think I forgot who writes it. Some scholar famously remarks pre-Socratic scholars were extremely dogmatic. So when you do not question your own beliefs, then you become dogmatic. And there's a good amount of evidence to suggest that pre-Socratic scholars, philosophers especially, they would sometimes just dwell into what you would call a quasi religion or something, some sort of, they become some sort of religious figures, because they're like, this is what I believe and this is absolute, everybody must follow this or else you are heretics. So philosophy, especially epistemology, did a huge favor to the world, that they said it's okay, nothing is absolute, everything can be questioned, let's all sit down and question what we already know. And I think these are the footsteps that later that Socrates is said to have been really famous for. I know that I do not know anything. So I think it played a huge role. When you shake the foundations, it humbles you. So philosophers and scholars, they are sometimes at the ninth cloud, but when you shake your own foundations, it sometimes humbles you down, and you're like, maybe everything I know is wrong. And I think the right way to proceed with it is not to take it on a personal scale and be like, if nothing is wrong, if everything is a simulation, if everything is not reality, then I don't need to do anything. But maybe you can think of it like, if maybe everything is true, maybe it is not true. But you know what? It gives me a chance to reevaluate myself every single second. So I think in this way, epistemology did a favor to all the world, that it saved us from many to be tyrants and dogmats, because we believe we introduce checks within our own knowledge. So we are continuously checking if what we are thinking and understanding is correct or not. And I would argue that is what gave birth to science as we know today. So this is my understanding of why epistemology is important, why philosophy is important in general. And I think we'll end with this.
All right.
It was a really interesting session. If we missed anything, if we misinterpreted anything, feel free to engage and let us all learn together. Because as Socrates said, we know that we don't know anything. And with that, thank you so much for watching. Thank you so much, Bill, for joining. I'll see you next week.